And hello, welcome to this video. I'm talking about IT stuff. Internet address and networking, computer networking for non-IT people like myself. Okay, so learn along with me. Okay, I am not an expert in this, but I'm learning this as well. So I'm making a log of the stuff I'm learning, just to clarify some concepts, and hopefully that will help you as well if you are finding it confusing as well. So last video, we are talking about a switch and how Ethernet enables the switch to send and receive Ethernet frames, which are like envelopes and mail between small computers, and the way that the switch knows where to send these pieces of mail is through something known as the MAC address. So we haven't really described the MAC address before, but we can talk a little bit more about it now. So MAC addresses, they are basically hard-coded into your system, and MAC addresses are usually hard-coded into your system by the manufacturer, so they are fixed like a car serial number. Okay, so if you have a car, more or less, you will have a car plate number of some sort. Okay? You have a car plate number. Okay, usually doesn't change. Of course, you can change your car plate number, but I guess there is some sort of unique identifier number that is associated with your car. Okay, and this doesn't change over time. It is assigned by, I guess, the authority in charge. And of course, each car has a unique identifier number as well. Yeah, in the States, it's called the VIN number. VIN number. Okay, and this is always fixed to your car, no matter what happens, no matter if you change your car plate number. So I don't know what it is like for other countries, but I know for the States it's with the VIN number. So it's a unique identifying number for for the car we use VIN number in the States, but let me change this. But for PCs we use this thing called MAC address. Okay, MAC address. And what does MAC stand for? MAC does not stand for iMacs in Apple. MAC doesn't stand for what do you call that? MAC does not stand for the iMacs in Apple, but they stand for this thing called Media Access Control. Don't ask me why that's the name. I'm not that clear myself, but you can see here MAC addresses are primarily designed by device manufacturers, assigned by device manufacturers, and therefore are known as burned-in addresses or Ethernet hardware addresses of physical address. So I like to say, in a sense, they are like your car plate number or what have you, even though it's not exactly your car plate number. And each of your cards will have a different MAC address. So, for example, let's take a look here. I'll run the command IPA in my Manjaro Linux. So, where do you find your MAC address? You will find it here on your link ether. There is one MAC address here for the Ethernet. Okay, ATFA5B806B4B. Okay, for the wireless card, there's yet another MAC address. This one is C858C025DFB9, something like that. Okay, and then you'll see this thing BRDFFFFF. Okay, what is all this, and what format is all these numbers over here? They're like 16 numbers, or 16 alphanumeric numbers, or 12 alphanumeric numbers, and they are separated by these colons. What is this talking about? Okay, Okay, so this is something known as hexadecimal notation. Okay, hexadecimal notation. Okay, you may or may not have heard of hexadecimal notation before. I'm guessing you may not have not, or maybe you have heard it once but you have no idea what it is. So let's explain it to you. Let's start from something we are completely more familiar with, decimal notation. Okay, decimal notation. Deci means 10. Okay, this is what we are used to every day. Deci means 10. So there are 10 possible numbers, right? Yeah, the 10 possible numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there are 10 numbers down here. And so if you write the number 97, okay, so there are 10 numbers, 10 possible numbers that can be in the tens place, 10 possible numbers that can be in the zeros place, and the maximum number of numbers you can fill in with these two spaces is 10 squared equals to 100 numbers, and the numbers you can fit in to two spaces are 0 or 0, 2, 9, 9. Okay, so this is 100 numbers. Now the second kind of notation that you may or may not be familiar with, or maybe be slightly less familiar, is binary notation. Okay, binary notation, you only have two numbers here. Okay, zeros and ones. This is the standard notation for computers because you have a on and off switch. Okay, on for high voltage, off for low voltage. Okay, so if let's say you want to represent the number 1 in binary, okay, you just have 0. I mean, if the number 0 is binary, is 0, 1 in binary is 1, 2 in binary is you set the first number to 0 and then you carry over the 1 over. Okay, you carry over the 1 over and then this will become 2. Okay, so let's check. Okay, 2 in binary. Okay, so this is what, 0B10. So yeah, this is how you change it to a binary number. So okay, decimal to binary converter. So enter decimal number and you can convert. The binary number is 2. So you convert that over and then that will become the binary number 2. And to get the binary number 3, well, you start you increase the ones place first, so to speak, or the first number. This becomes number 3, and so on and so forth. So if you want to do number 4, you have to carry on over. This is number 4, so on and so forth. So this is how binary works. So instead of going from 1 to 10 in the first number place and then you carry over 1, you actually go from okay, instead of going from 0 to 9 in the first numbers place and then when you get to 10 you carry over the 1, you go from 0 to 1 in the first numbers place and then you carry over 1 when you want to shift it to 2. So this is binary notation of numbers. Okay, so now let's deal with hexadecimal. So let's examine the name. The name hexa means 6, because like hexagons means 6. Hexadecimal, deci means 10. So this is actually 16. Okay, so instead of having 10 numbers in your first number place, instead of having 10 numbers, you will have 16. But wait a minute, you only have 10 numbers here. How do you make 16 numbers? So instead of having just 0 to 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Not just that, you have to so-called invent 6 other numbers. So the 6 other numbers are just simply English alphabets: A, B, C, D, E, F. So these become 16 numbers. So if let's say you want to use the number 9, well, number 9 is here. Alright, number 9 is here. But if let's say you want to go to number 10, you don't write this number 10 anymore. You don't skip it over. you go to the letter A. Yeah? A means number 10. Okay, 9 is 9. A becomes 10. And F here will be number 15. Okay, so F equals to 15. So that's how we do it. And then when you want to go to the next number, number 16. Number 16 will be, you hop on in the second place here. From 0, you hop on to 1, and then the first part will be 0. So when you see 10 in hexadecimal, this is actually 16. Okay, this is the only time you can write 10 equals to 16 if you're talking hexadecimal, right? Okay, so let's try hexadecimal to hexadecimal converter, and then I will put this here. I want number 16. I will convert this. The hexadecimal is 10. I'll have 25. Hexadecimal number is 19. So hopefully this doesn't complicate things too much. Okay, so yeah, I'll just leave this here. I'll just leave this here for you. I will put this in the description so you can go and play around with things later on. Okay, so long and short of it is that MAC addresses like to use hexadecimal notation, and this is what hexadecimal notation looks like. And every wireless card, every wireless card and everything will have its how do you say? Every wireless card, everything will have its own MAC address. And how many hexadecimal digits do you have here? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 digits. Okay, so remember, it's with 12 numbers, you can actually have 16 to the power of 12 notations. Okay, this is the same as 2 to the power of 48. Okay, this is a lot of possible unique MAC addresses you can have. So 2 to the let's do 16 to the power 12. It's this is huge. Okay, 2 to the power 48 is the same. Okay, equal 2 to the power 48 is the same. This is the number of possible MAC addresses you can have. So if you divide this by, I guess, the world's population, 7 equals this, divide by 7 E9, maybe world's population approximately 7 billion. You have, each person can have 40,000 MAC addresses if you divide it throughout equally. So it's possible, it's entirely possible for every single device on the planet, or every single network card to have a unique MAC address. Okay, so that is how things are. MAC addresses are unique for every single piece of hardware you have. Where the hardware can be, in this case, you can see there's an Ethernet card I have here. It has one MAC address, and then now even the wireless card has a different MAC address, and so on and so forth. Okay, so these are what you get when you do it with Linux. Okay, now I want to go on to the next segment. Okay, I will cancel this. Now cancel this. I've explained what hexadecimal is and how that actually is the format of MAC addresses. So let's say you have this setup, right? 4 computers connecting to a switch. Okay, all you need now is a MAC address of each of these computers. Okay, so let's say when you connect to the switch will kind of know the MAC address of A will be connected to this port. So maybe this is called port 1. I'll call this port 1 or something. I don't know whether the nomenclature is right, but that's how I'm thinking of it now. I'll call this port 1, this port 2, port 3, and port 4, right? Okay, so the switch will kind of when it receives this mail, it will ask, what computer is connected to this port. This port number 2. Okay, port number 2 will be port number 2 will contain this B computer. It will have this MAC address, so it will just send this thing over. Port 3 will have computer C with a certain MAC address. If A wants to send to the MAC address of C, it will go over. So it will ask the question, what MAC address is connected to each port, and does the MAC address of each computer, does the MAC address of each computer correspond to this the Ethernet frame here? Okay, because that's what the Ethernet frame will contain. It will contain the MAC address of the sender and the receiver. Okay, so it will ask, it will ask at least 3 times. Okay, 1, 2, 3. Okay, does your MAC address match the address of this packet? Okay, if not, then I'll go to the next one. Does your MAC address match the address of this packet? If not, then you'll go to the next one. Does the MAC address match this MAC address of this packet? So yeah, this for small scale systems is fine. What about if I connect 50 PCs, right? 50 PCs to this thing. 50 PCs to a switch. Okay, 50 PCs to a switch. Okay, if I connect 50 PCs to a switch, if you want to really up the game, right? We are not just connecting, 4 PCs to each other and want them to talk. We are talking about large scale things where we want to send email to people all over the world. You're going to need to connect more and more computers to a network. Okay, so we need many computers to talk to each other. So let's say you have 50 PCs. So every time one PC wants to talk to another PC, it will have maybe 49 MAC addresses to go and check, how many does this MAC address correspond to this Ethernet frame? Does this MAC address correspond to that Ethernet frame? So on and so forth. And you can imagine 50 PCs trying to talk to each other across the switch. This guy here will have a very hard time, trying to figure out what's going on. Okay, so now let's scale it up even more. Let's have 5,000 PCs. And you can see this is going to become a big problem the more you scale up, because the number of what the switch is trying to do, the switch is trying to do by default is to check whether the MAC address of the letter of this Ethernet frame will correspond to the MAC address of any one of these computers. In this case, you have to check 5,000 times almost every single packet you come. And remember, 5,000 PCs is not just one PC talking to the rest of the 4,999. All 5,000 want to talk to each other at the same time. So you can see this problem really scales up badly as the more PCs you add. So is there a solution to help us alleviate this problem, okay, of scaling up? Okay, so you cannot just rely on MAC address. Okay, you cannot just rely on MAC address. We will have to add another layer of, you got to add another layer which groups together sets of MAC addresses. Okay, so instead of the idea is that, okay, instead of having 5,000 PCs talking to each other at the same time, well, maybe you can divide it into 5 groups of 100 PCs, right? 100 PCs. So there's group A, group B, group C, group D. 5 groups of 1,000 PCs each. Okay, maybe. Or maybe 10 groups of 500 PCs, whatever it is, right? So and then you start having you start making life a bit easier for yourself. Okay, maybe I'll just have I'll divide it into groups of 200 PCs each. So 200 group A, 200 group B, 200 group C, 200 group D, so on and so forth. And they'll not all connect to a switch. Okay, so let's say each of these 200 PCs will have a unique address. Okay, so we don't just sort things out by MAC address. You need to assign a different kind of address to each, well, network. Okay, because each 200 PC group, we call it a network. So this is a network. Okay, and if you have many networks talking to each other, okay, you will need another sort of address. You need. Okay, so it's called internet protocol. So what LAN, okay, what Ethernet is for the switch here, for computers talking to each other across a switch, let's say 4 computers talking to each other, you use this Ethernet protocol. Okay, so if you replace each computer with a network of maybe 200 PCs, what's the protocol they use? So they have to use Ethernet protocol for sure, because that's the lowest level, or at least in the correct terminology, the second lowest level, but it's one of the lower levels. The layer above it, if you want the networks talking to each other, you use internet protocol. Okay, internet because it's really what it means is inter-network. Okay, inter-network. So internet. Okay, this is getting crowded. let's delete this, and you delete this. Oh, see, you delete. Okay, delete. This is actually inter-network. Okay, internet is really inter-network because you're talking between networks, and each network will have a unique address. Now, what is this address called? Well, now you'll have something very familiar. Internet protocol is actually what we know as IP. Okay, IP, and the IP, the internet protocol address is also known as IP address. So, well, welcome to the world of IP addresses, where each network will have its own address. And actually, IP address is not just the network address; it's network plus host. But I'll get to that shortly. Okay, so but anyway, this is why we have IP addresses. So if you're wondering why we have a hardware Ethernet address over here, and then we still need this IP. What's the use of all these addresses? The reason why these addresses are here is just to address the problem of scale up. So welcome to the world of IP addresses. I'm glad you made it here. Yeah, and so welcome to the world of IP address, which we are not just talking about. We are not just talking about computers talking to each other, but rather networks talking to each other. So if you have 5,000 computers, you don't have to ask, does the MAC address match this computer 5,000 times? You can just ask whether, okay, now that I have an IP address, right? The sender will have an IP address, and then the receiver will have an IP address. I can just ask, instead of 5,000 times, maybe I ask 20 times, because there are 20 networks here, or maybe 25 networks of 200 PCs each, for example. How many let's see, yeah, if I have 225 networks, I can just ask the if question: does the IP address of the sender, what do you call that? Does the IP address of the sender, IP address of the receiver match any of these 25 networks? I only need to ask that question 25 times, rather than ask whether the MAC address matches 200 plus times, And not only that, based on the IP address, you can kind of narrow down that even. So if let's say the first few numbers of the IP address says that I only need to narrow down the question to my first 3 networks, okay? Because some IP addresses you can just tell, it will tell this guy, say, okay, I only need to look at this group of networks, then yeah, it is perfectly fine. Okay, so okay, let's just take a look at what I'm talking about. So for example, over here in the United States, there are literally 1.5 billion IP addresses. So if you have the number 100 here, you can sort of be sure they are inside the United States. Whereas over here in Nigeria, you'll never see an IP address beginning with the number 100. So Nigeria has about 3 million IP addresses. Okay, none of them seem to start with the number 100. So just based on the first three numbers, and if I have an IP address of 100, I can just eliminate the IP address, all the IP addresses in Nigeria. So I don't have to ask the question, is my network inside Nigeria? I don't have to. So once I know that my IP address starts with 100, I can just straight away narrow down my search to networks existing within the United States. Okay, this is, I mean, of course, this there will be some overlap between countries. Let's say 102. Okay, 102 will be present in Nigeria as well. Can you see? Okay, okay, but long and short of it, these IP addresses actually help us to narrow down where we need to search for networks. Okay, so that's the nice thing. It's not just some random collection of numbers. These numbers actually help us to organize, where should we search for the destination. Okay, based on these numbers. Okay, so first three numbers will help you to sort of will help the network sort of decipher where should I send my packet. Okay, so that's just introduction of IP addresses. There are lots more to go on, but I'll stop for now lest the video becomes a little bit too long. Okay, so I'll see you guys next time, and thanks for watching.